So good morning everyone. In the previous video we have already seen that if you are given a continuous function or an explicit function, how we can find the least square approximation for the same. So now in this video we are going to see the least square approximation for the discrete values. So in this we need to derive the least square straight line and quadratic line quadratic fit for the discrete data xi, fi, I goes from 0, 1 to up to so on n. Okay, so now for this, if we are considering a straight line, then let us consider one general equation, that is, let p of x will be equal to c0 plus c1x. Okay, let it be a straight line approximation. Then what we have is, if we have a discrete data, then we have the formula for I c0, c1. So what is this? It's the summation I running from 0 to n f of xi minus ci xi whole square, and it should be minimum. Okay, so now if we find normal equations for this, then what we get is so to get the normal equation, we have to find the partial derivative of I with respect to c0 and c1. So partial derivative of I with respect to c0 is summation I running from 0 to n 2 of f of xi minus c0 plus c1 xi, which is equal to 0. Okay, so that's the partial derivative. Again, partial derivative of I with respect to c1 equals to summation I running from 0 to n to f of xi minus c0 plus c1 x1 into xi, which is equal to 0. Okay, so if we conclude these two equations, then what we get is c0 into n plus 1 plus c1 into summation xi equals to summation of f of xi. Okay, and c0 summation of xi plus c1 summation of xi square equals to summation of xi f of xi. Okay, so whenever you are given a discrete data, you have to find summation of xi. F of xi will be given, so we have to find summation of it, and we have to find xi square and its summation to get this values. Okay, so we'll just get the values, substitute in this equation. These are the most important equations with respect to discrete data. No need of solving this, just get the formula, substitute the values, and you will get the answer. Okay, so this is for linear approximation. Okay, now in terms of second degree least square approximation, what we have is, so for second degree approximation, so what is the general form of quadratic equation? It is a plus bx plus cx square. Okay, so now we will directly see what are the normal equations with respect to this. Okay, so that's the most important thing, the formula, that is an plus 1 plus b summation xi plus c summation xi square equals to summation of f of xi. Then second one is a into summation of xi plus b into summation of xi square plus c into summation of xi cube, which is equal to summation of xi into f of xi. Now the third one is a summation of xi square plus b summation of xi cube plus c summation of xi raised to 4, which is equal to summation of xi square f of xi. Okay, so these are the three normal equations with respect to quadratic approximation. You have to just by heart this two types of normal equation. This is with respect to linear approximation. This is with respect to quadratic. No need of by hearting the way or the derivation of it. Just keep in mind the formulas, and based on this formulas we will see few examples. So our next example is obtain the least square approximation that is a straight line that fits the following data. Okay, so data is what? X and f of x is given. So x equals to 0.2, f of x equals to 0.447. Next is 0.4, 0.632, 0.6, 0.775, 0.8, 0.894. The last one is 1. Okay, so we have given x1, x2, x3, x4, x5 and their respective f of x. So now what we have to do is to find the solution. First thing is write down what is given. So again you have to draw this table. Whatever it is given, x and f of x. Okay, so write down again the values. Now next step is to find summation of xi. Okay, so we have to find 0.2 plus 0.4 plus 0.6 plus 0.8 plus 1, which is equal to 3. Then next is summation of xi square. So you have to find square of this each term, that is 0.2 square plus 0.4 square plus 0.6 square plus 0.8 square plus 1 square, that is 1. So the final answer is summation of xi square is given by 2.2. Okay, now the next one is summation of f of xi. So summation of f of xi, so xi, f of xi is given, you have to just add it. So the answer is 3.748. Okay, now next one is summation of xi into f of xi. Okay, so what you have to do is we have to find a multiplication of this and then add. So the final answer is 2.5224. Okay, normal equations for fitting a straight line let's consider as p of x or p1 of x, because we are going to find both, right? Or no, just p1 of x, right? So which is equal to c0 plus c1x. That's the general equation. So now what are the normal equations we have studied? It is c0 into n plus 1 plus c1 into summation of xi, which is equal to summation of f of xi. Okay, so c naught is given. N plus 1 is what? So what's the value of n plus 1? It is 0, 1, 2, 3, 4. So n value is 4. So n plus 1 is 5. Okay, because our x starts from x naught. It is x naught, x1 up to so on xn. So our total value for n plus 1 is 5. So now plus c1 into summation of xi. Summation of xi is 3, which is equal to summation of f of xi. Summation of f of xi is given as 3.748. So our final normal equation is 5c0 plus 3c1, which is equal to 3.748. That's our equation 1. Okay, so similarly we will find the second normal equation. So this is c0 into summation of xi plus c1 summation of xi square, which is equal to summation of xi into f of xi. Okay, so now c0 into summation of xi is what? It is 3 plus c1 into summation of xi square, which is equal to 2.2, which is equal to summation xi f of xi, which is 2.5224. Okay, so this is what? 3c0 plus 2.2c1, which is equal to 2.5224. So this is a second normal equation. So again we need to solve this both the equations. So solving it, what we have is multiplying equation 1 by 3 and equation 2 by 5. Okay, so we'll multiply equation 1 by 3 and equation 2 by 5, and we will subtract it from each other. Subtracting from each other. So what we have is 15c0 plus 9c1 equals to 11.244 minus 15c0 plus 11c1 equals to 12.612. It is equal to minus 2c1 equals to minus 1.368. Okay, so what's the value for c1? c1 equals to 0.684. Okay, so we got the value of c1. Again substitute it in any of the equation. So to get the value of c0, what we are going to do is 5c0. We'll substitute in this. So 5c0 plus 3 into c1. So c1 value is 0.684 equals to 3.748. Okay, so then solve it for c0. So 3.748 minus 3 into 0.684, the value for it is 2.052. So 5c0 equals to, subtracting this, so c0 equals to 0.3392. Okay, so now we got the value of c0 and we got the value of c1 here. So now the required equation is the required equation of approximation. That is, required approximation is p1 of x equals to, now what is that? So we had considered p1 of x, right? p1 of x is c0 plus c1x. So c0 is 0.3392 plus c1 into x. So c1 is this. So 0.684 into x. Okay, so this is a required approximation. So again there is one another concept like least square error. Okay, so to find the least square error, there is a formula which is summation of I running from 0 to n f of xi minus whatever the approximation function is. So here we have 0.3392 plus 0.684x. Okay, so this is the approximation function, so square. So instead of x we will substitute xi. So to calculate this, what we need to do is, first we need f of x naught minus 0.3392 plus 0.684 into the respective x1. So x1 is respective x naught. So what is the value for x naught here? It is 0.2. So we'll just substitute f of x naught is 0.447 minus 0.3392 plus 0.684 into 0.2 plus again with respect to this all. So we have to find summation of it. So if you find with respect to this, you can calculate it, okay, in the rough, and you will get this value as 0.00245. Okay, so this is a minimum error when we follow the least square approximation method. Okay, so now let us move on towards our next example. So find the least square approximation of second degree for the discrete data. Okay, f of x is given, x is minus 2, f of x is 15, and minus 1, 1, 0, 1, 1, 3, 2, 19. Okay, so this is your given data x and f of x. So what we need to do is, we have to find least square approximation. So again, see, if you are asked this question for more than 5 marks or as such, then you can have a perfect table. So let's see how we can have it. So as you have solved it in statistics, so you can do like this. So f of x, so it is minus 2, minus 1, 0, 1, 2, and f of x is 15, 1, 1, 3, 19, right? So we need to find summation of xi. So summation of xi can be given as, so you have to find this, so it is 0. Now again, summation of f of xi. So what's the value for summation of f of xi? It is 39. So next is what? We find xi square. Okay, so these are your xi, these are your f of xi. So now xi square, so you need to find square. So 4, 1, 0, 1, 4. So summation of xi square is 10, right? 4 plus 1 plus 1 plus 4, 10. Then we need to find x cube. So x cube is what? X1 cube, sorry. So we have to find xi cube. This is what xi cube is, 81018. Then summation of xi cube will be equal to, again, minus, this will be minus, sorry, this will be minus, this will be plus, right? So again it will be 0. Then xi raised to 4. So yeah, we need to find the fourth power of it. So it will be 16, 1, 0, 1, and then again 16. So we need to find summation of xi raised to 4, which is equal to 34. Okay, now summation of f of xi, we have already find it out. So now xi into f of xi, we have to find this multiplication. So just multiply. Minus 2 into 15 is minus 30. Minus 1 into 1 is 1. Minus 1, then 0, then 3, and then 2 into 19, which is equal to 38. Okay, so then we find summation of xi into f of xi. So summation of xi into f of xi, it is given, so it will be what? Minus 30 into plus 38. So minus 30 plus 38, so 8 minus 1 is 7, 7 plus 1, 7 plus 3 is 10. Okay, so now next is what? Xi square into f of xi. So we have already found value of xi square into f of xi. We have to just multiply this. So 15 into 4 is 60. 1 into 1 is 1, 0, then 3, and 19 4s are. Okay, so summation of xi square f of xi can be given as, so we have to just add this. So the answer is 140. Okay, so we got all these values. So then we have to substitute these values in the normal equations which we have already seen. So the normal equation for second degree polynomial. So let that polynomial be p2 of x equals to c0 plus c1x plus c2x squared. Okay, so as we have studied, so a into n plus 1 plus b into summation of xi plus c into summation of xi square equals to summation of f of xi. Okay, so that's our first normal equation. So substituting its value, so with respect to c0 c1, we can consider as, so this will be c0 into n plus 1 plus c1 into summation xi plus c2 into summation xi square equals to summation of f of xi. So I had written it in the form of ax plus by plus ax square plus bx plus c. So if we have here c0 plus c1x plus c2x square. So now c0 into, so how many values we have? So it is 5 plus c1 into, what is the value of summation of xi? We have it as 0. So subtracting 0 plus c2 into summation of xi square. It is 10 equals to summation of f of xi. So summation of f of xi is 39. So what we got is 5c0 plus 10c2 equals to 39. So this is our first normal equation. Then what is the second one? So c0 into summation of xi plus c1 into summation xi square plus c2 into summation of xi cube equals to summation of xi into f of xi. Okay, so c0 as it is, summation of xi is again 0 plus c1 into summation of xi square, it is 10 plus c2 into summation of xi cube, so it is 0 equals to summation of xi f of xi. So value for it is summation of xi into f of xi here. So it is again 10. So what we have is 10 c1 equals to 10. So from this directly we got value of c1 to be 1. Okay. Then the last equation. So again c0 into summation of xi square plus c1 into summation of xi cube plus c2 into summation of xi raised to 4 equals to summation of xi square f of xi. Okay, so again substituting the values, summation of xi square is 10 plus c1 into summation of xi cube, it is 0, plus c2 into summation of xi raised to 4, it is 34, equals to summation of xi square f of xi, it is 140. Okay, so what you got is 10 c0 plus 34 c2 equals to 140. Okay, so now with the help of this two equation, you can find value for c0 and c2. So I'll write down direct values. So c0 equals to minus 37 upon 35. Then what we got be c1 as 1 and c2 will be 31 upon 7. You need to solve this equation. Okay, so there are two unknown variables, so there are variables in two equations, right? So this is your sum of least square approximation with respect to discrete data. Okay, so now the final step is writing down the linear equation. So the required equation is P2 of x equals to 1 upon 35 into minus 37 plus 35x plus 155xy. Okay, so that's a required approximation or quadratic approximation. Okay, so our next point is weighted least squares approximation. Okay, so in all the previous examples, what we have seen that we were not given any weight or like w of x value, so we used to consider it as 1. So now in this next whatever the problems we are going to solve, weight of certain values will be given. So where w of x will be given for every values of x and y, okay, or x and f of x. So let's see how it goes. So let fy equals to a0 plus a1 x. So this let us be the straight line. Okay, let it be a straight line which is to be fitted to the given data points. So suppose you have given some data x1 y1 comma x2 y2 up to so on xm yn. Okay, previously we used to say f of x1, f of x2, f of xm. So here we are going to use another notation, that is y1 y2 up to so on yn. So now s of a0 a1. Okay, previously I used to find I of a0 a1. So in this weighted least square approximation, I'll consider s of a0 a1, which is equal to summation of I running from 1 to n wi over yi minus a0 plus a1 xi whole square. Okay, so this is our s of a0 a1 equation. Now the system of equations with respect to a0 and a1. So what are these equations? So a0 equal a0 into summation of I running from 1 to m w of I plus a1 into summation of I running from 1 to m wi xi, which is equal to summation I running from 1 to m wi yi. So this is the first equation. We need to just consider or keep in mind this equation. This is your first normal equation, and the second one is a naught into summation I running from 1 to m wi xi plus a1 into summation I running from 1 to m wi xi square, which is equal to summation wi xi yi. I goes from 1 to m again. Okay, so this is your second normal equation, this is your first. So with the help of these two equations, we need to find the whatever the linear approximation is. Okay, so we will see few examples. So suppose there are experimental values given for x and y. So they are in the pair 0, -1, 2, 5, 5, 12, 7, 20. Okay, so these are the pairs for x and y, values for x and y, and there are the weight is prescribed for each point. Okay, so each point in the sense weight is given. So weight for 5, 12 is given as 10. Okay, so this is given, and all other weights are to be considered as 1. So for this, if the straight line is which is y equals to a naught plus a1x, this is a general form. So we have to fit this line into this pair of points, that is 0, -1, 2, 5, 5, 12 and 7, 20. So we need to find again, we need to plot one table again. So value of x, y. So x is what? 0, 2, 5, 7. Y is -1, 5, 12 and 20. Okay, so what is the weight given? So w is, so we have given 0, -1, so weight is 1. 2, 5, it is given as 1. 5, 12, it is given as 10. So this is the exception case, and then 5, 20 is again 1. Okay, so now whatever the formulas are, we need to find the quantities with respect to this. Okay, so now we need to find summation of wi. So again, summation of wi equals to 13. Okay, also we need to find what? Summation of wi xi. So for that, find wx. Okay, so we need to just multiply it. So 0, 2, 57. So summation of summation of wi xi is equal to, so summation is 59. Okay, and then next point is what? We need to find some wi xi square. Okay, so this is what we need to find. So then xi square is what? 0 square is 0, into 1 is 0, 2 square is 4, 4 into 1 is 4, 5 square is 25, into 10 is 250, and what is 7? 7 square is 49, into 1 is 49. Okay, so this again, the summation of wi xi square is 303. Okay, after adding this we get 303. Now next one is what? W into y. So this is wi and wi. So multiply this. So -1 into -1 is -1, 5 into 1 is 5, 12 into 10 is 120, 20 into 1 is 10. So again, summation of wi will be given as 144. Okay, so this is what it is. Now what is remaining? This is, okay, this is remaining. So wi xi yi. So again, wi xi y. So we need to multiply all these three. So we get 0, then 0, 10, then this will be 5 12 is 60, 60 and 600. Then this will be 140. Right? So summation of wi xi yi will be equal to 750. Okay, 750. Okay, so these are the values we got. So we need to substitute this in both the equation. So what we have is a naught into summation of wi, I running from 1 to n, plus a1 into summation I running from 1 to n wi xi, which is equal to summation I running from 1 to n wi yi. Okay, so substituting all the values, what we get is a naught into summation of wi is 13 plus a1 into summation of wi xi, which is equal to 59. Okay, equals to summation of wi yi, which is equal to 144. Okay, so this is our first equation. Now second one is what? A naught into summation wi xi plus a1 into summation of I running from 1 to n wi xi square equals to summation I running from 1 to n wi xi yi. Okay, so again substituting the value a naught into, so what are the values we have? So wi xi is 59. So a naught into 59 plus a1 into wi xi square. So wi xi square is 303. So it is 303 equals to summation of wi xi yi. So we got it as 750. So this is our second equation. Okay. So multiply equation 1 by 59 and equation 2 by 13. Okay, and we need to subtract it from each other and subtract them. So what we get is 767 a naught plus 3939 a1 equals to 9750. Then minus 767 a naught plus 3481 a1 equals to 8496. So solving this, what we get is 458 a1 equals to 1254. So a1 will be equal to 2.73799. So that's our equation 3. Okay, now we need to substitute this value of a1 in any of the equation 1 or 2. So substituting it, what we get is, so let us consider this equation 13 a naught plus 59 a1 equals to 144. Okay, so this is our equation. So that's the equation 1. So substitute, so 13 a naught plus 59 into 2.73799 equals to 144. So value for a naught is, a naught will be equal to minus 17.54141 upon 13. A naught will be equal to minus 1.349345. Okay, so we got the values for a naught and a1. So the required least square approximation will be y equals to minus 1.349345 plus 2.73799x. Okay, so this is the required linear approximation. Okay, so there is one homework for you, so you need to work it on yourself. So solve the above example. So you need to solve this example but we have already solved, but there is just a change in it, that is you need that's the weight is different. Okay, so solve the above example again with increased weight. suppose say 100, okay, corresponding to y of 5 comma 0. Okay, so just change the weight of 5 comma 0 as 100 and let other be as it is. Okay, so as it is, that means 1. So this is the homework for you. Just solve it. If there is any problem, you can ask it, and I'll share the PDF as well, so look and just go through it, and if you have any problem, just ask me. And the last thing is, in few cases I have used shortcut while writing in the PDF format, so you need to solve them. For example, if two equations are given, I have directly written down values for a0 and a1. You are supposed to solve this equation while writing down the paper. Okay, so keep in mind, if you are taking down the notes with the help of PDF, then just keep in mind you need to solve all the equations.